Lopa, what are they doing to Lopa?
We just started conics today.
Phonics. Okay. What are you doing in school, Ashita?
Right now, we're gonna have a test on logarithmic functions on the 22nd. So we learned that and we did what is it called?
Logarithmic function, are you graphing now? Sorry to interrupt.
Graphing, that was I think we already like did a test on that one, but right now we're doing like log and like the Richter scale and
Oh, yeah, yeah.
yeah.
Log based functions, huh?
Yeah, we're doing like log equations and like that.
Makes sense. Okay. You're doing conics, Alopa.
Yeah. Also,
How is
Miss
conics
Privilege.
going? Huh?
Oh, I just want to let you know I have to go at 6:30 today.
Sure, ma. For Ashrita, would it help if we cover logs? That's what I am planning to cover. Though conics, did we do, ma, Ashrita?
I don't think so.
Thanks. I have the feeling I did in one of the classes. I don't know if I did it in both the classes. Conics came in which unit?
It's unit 9.
Unit?
9 for us.
Unit 9. Is it module 9 in the book, ma?
I'm not too sure, but our
Conics was
teacher gives
covered
us.
in quadratic equations, right? I feel like we
I'm
did
not.
quadratic equations. Let me quickly check. What is this? I feel like I did it, but I don't know, ma, honestly. Wait. Otherwise, I need to check my notes. Hold on. I'll quickly check this. Otherwise, I'll go there and check. 1 second, wait, ma. Because conics, are you able to understand or do you need help in this?
We just started it today. We've only gone over like one part of the notes, but I kind of have been able to keep up. Like I kind of understand it. I got like the practice questions right.
I felt like it was in the earlier units, right? Conics.
I don't. We learned like circles in the beginning of the year, but with conics, it's more like on a graph type of
Yeah,
thing.
yeah, yeah. I get it, ma. Conics from the did we not
Oh,
cover at the start of
yeah.
this?
I think you did cover it. I think you did cover Miss Priya. I remember this.
You remember us doing it in
Yeah,
class?
yeah, yeah. It's like the focus and like the directrix
Oh,
point.
yeah, yeah, yeah.
Yeah, I do remember this. Yeah, I think that's why I kind of understand it better because it was like familiar.
Unit 5, right? Yeah, I did it in Unit 5. Did we do Mashita? 241,
I think we did do it, but I probably didn't understand it as much.
at that time, huh?
Yeah. And plus I don't think I even learned it in school yet either. And I heard that for
Oh,
us
you didn't learn it at all, huh?
yeah, because I heard that logarithmic functions is our last unit, but I don't think we learned anything like that. That's why I didn't know what the name of it was.
See, conics again comes in the conics again comes in pre-calculus. That's why they don't teach you properly.
Oh.
Same thing comes in pre-calculus.
Oh, okay.
Does that make sense?
Yeah.
Yeah. See, that's why they're not covering that as a part of. They're not covering it as a part of algebra 2. Okay, now I really want to move on. 13.4 and 14. I want to cover 13.4 and 14 as much as I can cover will do. Let's see. Okay. Shruti, how are you?
Oh, I'm good.
Okay. Are you all doing the homework, guys?
I actually didn't do the homework this week because I kind of just watched the recording.
Okay. That puts me in distress, you know. Okay. So, see, if you don't submit homework, you don't get back with questions. I lose the drive as well. That is also there, okay? I'll tell you honestly. It's so important to do what is given and ask some questions. That keeps me on check as well. If you guys don't do it, then how are we going to continue? I don't know. Whatever I will do, I will do. That's it. Because that's not going to help you guys, honestly. Mm, yeah, I was looking at algebra too, whatever homework I gave. 12 point, 13 point, okay. So it was all on 12.1, 12.2, 12.3, 12.2, 12.1, 12.3. Did we cover exponential decay functions and all? Not really, right? 13, we did not even start. Okay, so do you all remember geometric sequence? Okay, I'll go ahead and start with whatever I left off, guys, so that whatever it is a review. And one more thing, pre-calculus is a lot of exponential logarithmic functions. So I would really want to finish up this. Let's see. Put on the pin பண்ணி எடுத்துன்னு போகணும். Coming to exponential logarithmic functions, right? So do you remember geometric sequences? Let's see this one. How about this? N, nth term, okay? And then the term value. Let's try graphing it. 1, 2, 3, 4, 5, 3, 9, 27, 81, 243. Is this a geometric sequence or an arithmetic sequence?
Can you say it out loud or
Geometric.
Geometric. So, so how is it different? How do you say it's a
Because it's
geometric
getting
sequence?
multiplied.
Yep, it's getting multiplied by. So, what is the common ratio here?
3.
3. Okay, it's a growing sequence, right? So, the common ratio has to be greater than 1. So, if I plot it, right, 1 comma 3, 1 comma 3, 2 comma 9, it goes like this. So, go to 0, what happens? Divide by 3, right? 1, 0 is a 1. And then what happened to minus 1? Minus 1 is 1 by 3, right? So, it goes like this. Do you see? So, when you graph a geometric sequence, then you get an exponential function. Any questions on that? Since the common ratio is greater than 1, it's an exponential growth function. What's an exponential decay function? Suppose the same term. Let's say we are going to have like this. Suppose I have exponential decay function. Let's say for minus 3. Let's say minus 3 or minus 5. I have a 243. Okay, minus 3, I have a minus 27. Minus 2, I'll have a 9. Minus 1, I'll have a 3. So what is going on here? 0, I'm going to have a 1. Now 1, I'm going to have 1 by 3. 2, I'm going to have 1 by 9. 3, I'm going to have 1 by 27. So what is happening on that graph? Minus 5 is a 243 somewhere here. Minus 3 is a 127. And then minus 2 is a 9. And then 0 is a 1. So it goes like that, right? See, guys? So here when you look at the geometric sequence, what happens? Here, you go ahead and see this geometric sequence. This is the nth term. This is the term value, right? When you do this, you're dividing by 3 every time. When you're dividing by 3, what is your common ratio? Common ratio here is
1/3.
1/3. So it is less than 1. So this becomes an exponential decay function. So in the graph, the red marking says it's an exponential decay. The black graph shows it's an exponential growth function. Any questions on that? Can I move on? Can I move on? So now let's go ahead and write one more. See, this is a review only. We have learned this in algebra 1. Suppose if I have like this, right? Okay, now this one. Can we go ahead and write the explicit and the recursive rule of this function? Explicit and recursive rule of this function, would we be able to write? Would we be able to write, guys? Based on whatever is given. Should I write or do you want to do? Anything works, ma, but let me know.
Miss Priya, I'm not like too sure what this is. Can you explain it after?
Absolutely. You're not sure what is this. Explicit in the recursive formula for an exponential, for a geometric sequence. How do you write it?
Is it first term?
Yeah,
By
f of n will be equal to, how do you relate f of n and f of n minus 1? From the previous term, what happens? See, the common ratio is the successive term. Successive term is, this is 0th term, first term, second term, third term, right? I can do f of 1 by f of 0. Or I can do f of 3 by f of 2. Any two terms consecutively, I can do this, right? So what happens? That will be 24 by 12 or 12 by 6 or 6 by 3. So that is a 3. The common ratio is a 3. So nth term, let's say the second term is derived from 3
I
times
think the
f of
common
1.
ratios are 2.
What more did I make? Sorry.
Yeah.
Yeah, 2. Okay. So 2 times f of 1. So in general, I can write f of n is equal to 2 times f of n minus 1. That is the recursive formula which connects f of n and f of n minus 1. Explicit formula connects the first term. It is also an equation for the nth term. But it connects the first term times 2 power of n minus 1. Do you remember this, guys? Do you remember this?
Yes.
Yeah, in this case, what happens? F of, okay. In this case, right, I'm writing the first term of the sequence is 0th term is here, right? So I can say f of 0 times 2 power of n. If it is the first term, I will write 2 power of n minus 1. Any questions? If 0th term comes, this is n. If first term comes, that will be n minus 1. So one thing about the general formulas, explicit formula and the recursive formula here is, you will have to write your restrictions. What is the restriction? Suppose for the recursive, right? Recursive formula, we are connecting two consecutive terms. What are we doing? F of n is equal to 2 times f of n minus 1, right? In this scenario, n value, right? N value should be what? N value should be greater than or equal to 1. You cannot put n equal to 0 because you don't have the minus 1th term here. So n value can't be 0, but you can substitute a 1 here. If you substitute a 1, then it will refer to 2 times f of 0. You have the value in here. So n is greater than or equal to 1. Make sense, guys? Based on given terms in the table, you will have to define your restrictions for the formulas as well. In this case, since you have f of n minus 1, you can substitute n is equal to 1. But you cannot go less than that. So n has to be greater than or equal to 1. Any questions? Any questions? Manav, are you getting it?
Yeah.
Okay, now let's go ahead and do one more of this. I'm giving you a table. You're going to give me the recursive as well as the explicit formula. 1 by 25, 1 by 5, 1, 5, 25. If this is the case, right? I really want you to write the explicit. I really want you to write the explicit rule and the recursive rule for this table, for this sequence. So I want you to write what is f of n here, what is f of n here. Explicit formula relates the nth term with the first term. First term is the first term here. First term. recursive formula relates f of n with f of n minus 1. So how will you relate? You have to complete the formula. Can you complete and let me know? I can write it down, guys. Do you want me to?
Apparently I sent you my answer, but it's wrong. I meant to write
Oh, you sent your answer. I didn't see
yeah,
it.
I meant to write 5, not 1/5.
Yeah, n minus 1.
Yeah,
Yeah, but what is
5.
the restriction? Restriction should also be there, right?
Oh, okay.
Restriction should be n should be greater than or equal to. Anybody shout out, guys. Manav, that is incorrect. It's a decreasing sequence, right? Guys, in a geometric sequence, it's a decreasing sequence, right? What is the common ratio? Successive term by the previous term, right? It's not 5, right? Or it's 5?
It's 5.
5, it's 5. Sorry, growing term. But some of you have written 1/5, right? Let me check.
Yeah, I messed up. I was supposed to write 5.
Okay. So Manav got it right. Akash got it right. Okay, you messed up. Okay, some of you messed up. Okay, that's fine. So now R will be equal to 5. So if R is equal to 5, this is f of 1 times R power of, R is 5, right? Power of n minus 1. That being the case, f of n will be equal to 1 by 25, 5 power of n minus 1. What is the restriction? See, n can be 2. It can't be 1 because we don't have 0th term given. So n has to be greater than or equal to 2. And then here f of n is equal to 5 times f of n minus 1. That's all. Make sense? Ashrita Lopa, does it make sense?
Yeah, it makes
Yeah.
sense. I just didn't submit it in time.
Yeah, but
Wait,
did you
Priya,
yeah,
I,
Manav. I'm hearing you. What is it?
I was asking a question.
Sorry, what was that?
Why does it have to be greater than or equal to 2? Because you can still do n minus 1. See, if it was 1, then you could do 1 minus 1.
1, but
That
you
would give
don't
you
have the
0.
thing here, right?
But it's asking for n minus 1, not f of n minus 1. You could do 1 minus 1 and that would give you 0. So 5 to the power of 0 is just 1. So 1 times 1/25 is still 1/25.
This is f of n minus 1, right? What can you substitute for n? You can substitute 1. If you substitute 1, it would be 5 times f of 0, right? You don't have f of 0 here.
Oh, I see. You're saying it for the recursive rule too. I thought you were just talking about the explicit rule.
Both, both.
Okay, yeah, I see.
Even for the explicit rule, you
But it
can,
should work for the explicit rule, right?
no, right? If you put 1, if you put 1,
It still works because 1 minus 1 is 0 and 5 to the power of
okay,
0
okay,
is.
okay, okay. Then it's okay. Yeah. I realize what you're saying. This applies to your recursive formula. The restriction applies to your recursive formula.
Yeah.
Makes sense? Good catch. Can we move on? Can we move on? second. I just want to verify what I said. Hold on. How do I verify? For the explicit formula, do we have something? Do we have constraints? Yeah, it applies only to the recursive formula in that case. I've ensured. Okay, now let's go ahead. Exponential growth functions. Okay, how about this, guys? Suppose if I say f of x equal to 2 power of x, f of x equal to half power of x, what is the difference between the two, guys? What is the difference between the two? Any thoughts? What is the difference between the two?
One's decay, one's growth.
This is growth, this is decay. You know why? When you, as soon as you look at it, right, here, 2 is going on multiplied. Whenever you multiply a number by a number greater than 1, it grows. Whenever you multiply any number by a number less than 1, it decays. The value of the number reduces, right? So this is a decay function. This is a growth function. Any questions on that? Now, you should be able to write the domain and range for these things. Should I concentrate on that or can I move on? In terms of domain, it will be minus infinity less than x is less than infinity. Same here, minus infinity less than infinity less than, less than x is less than infinity. Then the range would be minus 0 less than, see, 0 less than y. 0 is never equal to y is less than infinity. For this one, it would be again 0 less than y. See, it's no. 0 is less than y is less than infinity. Any questions on that? Any questions on that?
No.
Okay, okay. Now, so what I meant to say was domain and range for both the growth and decay function are going to be similar. Okay, now how about this? 10 power of x equal to f of x. Is it a growth function or a decay function? Growth function or a decay function?
Growth.
Growth function. Now, if I ask you about this, 2 power of x plus 1 equal to h of x, what transformation has it undergone? So a general 2 power of x is like this. But what is this transformation? What is a transformation? What is the movement on the x, right?
The exponent gets added by 1.
True, ma, but what is the transformation? For every function, we have studied about transformation, right?
Right.
What is
Oh, isn't that left one?
left one? Left one means what happens? The entire graph, right, shift to the left by 1. Left by 1 means it goes like this. Make sense?
Yeah.
This goes 1 to the left. Now let's see this one. How about 10 power of x minus 2? How about this? 10 power of x graph is like this, right? 10 power of x minus 2 means what happens now?
It goes down 2.
It goes down by 2. So this is 1, this is 2. So down by 2, it goes like this. Any questions? Okay. Now let me move on and try this one. How about this? Okay, f of x equal to minus 5 2 power of x. What will happen to these? We'll just discuss the transformation. What are the transformations?
Reflection.
Reflection on what?
The x-axis.
Reflection on x-axis. And
then a vertical stretch.
Vertical stretch of 5. Okay, that's good. So reflection on x-axis means it will be like this. and then vertical stretch of 5. Vertical stretch of 5 means it is applied to the y, right? All y values get multiplied by 5, so it becomes very steep. Does that make sense? Make sense? Okay. You should be able to identify what transformation is involved in anything that's given to you. How about this? Let's go ahead and graph some of these. How about this? I really want to graph this one. Maybe I'll graph this one. I'll give one to you. Okay. Q of x equal to minus 3 by 5, 10 power of x plus 2 plus 3. So left to me, you know what? I would want to know what are the reference points for an exponential function. What are the reference point? This one. Naturally 0, 1. Right. And okay, if it is 10 power of x, right? Let's say x value is 0, y value is 10, y value is 10 power of 0, that's equal to 1, 1, then 10 power of 1 is a 10. So naturally 0, comma, the base value. I'm sorry, 1, comma, the base value. So these two are very good reference points, right? Now, can we find out what will happen to these reference points with this transformation? Meaning, what will happen to the point 0, 1 and 1, 10? Can we identify that from the transformation? First, let's write out the list of transformations. What are the transformations? Verbal description. Can we write out the verbal description? We'll go slowly, guys. What is that? Reflection on? Reflection on?
X-axis.
X-axis that affects the y coordinate, and then vertical stretch or compression.
Compression.
Compression by 3 by 5 that affects the y-axis. Then left by 2, up by 3. Now that affects the y-axis, this affects the x-axis. Okay. Now what happens? This is the parent transformation. I would really want the table to be drawn properly. You don't make mistakes. That's the transform function. X comma y was in here. So I said 0 comma 1 and 1 comma 10 are the only major points I'm going to be bothered about, right? So that being the case, what happened in the transform function? X value. First I need to write the value of x, right? X is left by 2 means x is just making a move of x minus 2 in the transform function. Coming to the y, there's a lot of changes. Y value first it reflects, it becomes a minus y. And then it gets multiplied by 3 by 5y. And then up by 3 means you're adding a 3. So minus 3 by 5y plus 3. Any questions on the transformation? Now x minus 2, now this becomes minus 2, this becomes a minus 1. I know we are only getting 2 points, right? It's really bad, not useful for graphing, but I will know how the points moved. Minus 3 by 5y, minus, substituting y equal to 1, minus 3 by 5 plus 3. What happens here? 15 minus 3, 12 by 5. So I'm getting here 12 by 5. If I substitute 10, if I substitute a 10 there, minus 3 times 2 plus 3 minus 6 plus 3 is a minus 3. Now, what can I say about the transformation? 0, comma 1, the transformed point is minus 2, comma 12 by 5. 1, comma 10, the transformed point is minus 1, comma minus 3. So, minus 1, comma minus 3 is a transformed point that this point moved to this point. The second one, 0, comma 1. This point moved to minus 2, comma 12 by 5. 12 by 5 is 2 point something, right? So somewhere here. So if I am right, you know, where is the asymptote? Asymptote is at 3. Do you see asymptote is at 3. So basically asymptote is somewhere here. Let's say this point is here. So now this goes like this graph, and the asymptote is here. This is y equal to 3. This is the asymptote. Do you see? Now our points, one point is here, one point is here. The graph goes like this. So when you think about it, it was basically a reflection on this graph, right? The red graph, how did it transform? Let's think about it a little bit. This graph first was reflected on the x-axis, right? It came down like this. Okay, not exactly, but yeah, it should have touched this point. Now it was reflected and then vertically compressed means it got a little bit widened. Okay, vertically compressed means it got a little bit widened. After that it moved left by 2. Basically it moved left by 2 and then up by 3. See, that's why it became like this. Any questions? So if you follow the sequence, right, you should be able to arrive at our final graph. Our final graph was this, right? So we should be able to arrive at it from our original graph as well. But the point transformations are usually hard. So you better draw a table and find out the point transformations. Can I give one more to you like that? Can I give one to you? Okay, let's try. Okay, how about this? Yeah, we'll do just one. You just tell me the points transformed and then we'll move on. Q of x equal to 2 times 3 power of x plus 2 minus 1. This is our function. Please tell me 0, comma 1 and what? What is the base? 1, comma 3. What is, these two are the reference point, right? What is the transformed points for these? You have to let me know. If you tell that, I know you'll be able to graph it. So just this and tell me what is the asymptote. So that will enable you to graph it well. In your calculator, you should be able to put your exponential functions and find out the regression equations, guys. If you need, please let me know, guys. I'll do it on the board, but I really want you to try. Super. Okay, that's good. 2, 1 minus 1. Oh, wow. Good job, Shruti. Ah, Shri, that is incorrect. Mano, are you able to do? So first write
Yeah,
out
I'm
the
still
verbal.
drawing the graph.
You're also drawing the graph, okay?
Yeah.
But did you understand how the points got transformed?
Yeah.
That's right, Shri. How did you get it now? First it was totally incorrect, right, Shri?
Yeah, I completely did the transformations wrong.
Oh, okay. Interesting. How do we change it? Lopa, are you getting how to do?
Yeah, we haven't like gone over this in school, so like this is
Amma,
my
there's
first.
no way, ma, they would have gone over this
We
100%. Any function, it's the same transformation, right? Meaning the
yeah,
transformation function, be it a cubic function, cube root function, absolute value function, square root function, square function, quadratic function, exponential function, logarithmic function. Any function, it's the same procedure, ma.
I just think I messed up on the transformations part of it.
You want me to help you with this or you're good?
Yeah, can you like explain this? Like
Yeah,
I think I got it.
Ashrita, how are you doing?
I don't get this. I was gonna ask you to explain it.
Amma, SCT exam is it's all involving all of this, right? I'm really worried. Again, you are all going to go for coaching for this, right? That's not useful, honestly. If you can understand this, for any function, it's like that. It's not only this is not new for us. That is why I didn't go over this. Basically, what are the transformations? I'll go ahead with a vertical stretch of 2.
Wait, Miss
Then
Priya, is
what?
my answer correct?
Left by 2. Wait, Manav. I did not see your answer at all, Manav. First, send
Mom,
your answer.
I have the paper.
Oh, please send your. Okay, Manav, my only problem is yes, that seems right. Okay, the graph, but I really want the transformed points that will accurately tell me whether you understood. Your
I'll
graph
put that
seems
in
very
chat.
correct.
I'll put that in chat.
Yeah, vertical stretch by 2, left. See, vertical stretch by 2, left by 2, down by 1. Right? This is applying for every graph. Now, vertical stretch means affects y, affects x, affects y. Now, what happens to my x points? Usually, originally, it was 3 power of x, right? X point, how did it transform? This is the only thing that got affected. X became x minus 2. All my x points became x minus 2. So, 0 becomes minus 2. 0 minus 2. 1 minus 2 is a, this becomes minus 1. Now, what happens to the y points? Originally, it was y. It was multiplied by 2 vertical stretch and then down by 1 means minus 1. So that became 2y minus 1. So now substitute y, 2 times 1 is 2, 2 minus 1 is 1. Now again 3. If you substitute a 3 in here, it becomes a 5. So the transform points are minus 2 comma 1 for this one, minus 1 comma 5 for this one. Makes sense? You need to be able to do this if you have understood transformation on any function. Coming to asymptote, y will be equal to minus 1. Hey, Manav, that is incorrect. The same incorrect answer, I got it from Shri. Shri, can you tell me what was incorrect? What did you do? He has got the same incorrect answer, Shri.
No, I mean, I just did my transformations wrong. I just plugged it into the equation. I completely forgot about the transformations thing. Then I went and actually like listed the transformations and I applied it to each point.
You plugged it into, oh, ho, ho, ho. I see. See,
Yeah.
that's what was the mistake you did so that I
Yeah,
can
because
tell
that's
Manav.
we're doing like we're learning about exponential and logarithmic like applications right now, like using word problems like simple compound, halftime, those type of things.
Yeah, that I get it. I'm going to go there, but this one, first of all, first this and after that.
Yeah.
Hey, Manav, did you substitute it directly in here?
Yeah.
That's not what it is, right? 0, comma 1. I am not asking you, see, Manav, you cannot substitute 0 into the original equation and tell me the value of y. That doesn't do any good. This is wrong. Okay, I am asking Originally, it was this function. In this function, the point 0, 1 and 1, 3 were 2 points, right? Now, you vertically stretched it. You vertically stretched it in the sense, vertically it became steeper, right? And then it moved left by 2, right? And then down by 1, correct? So it was like this, right? Now in the transformed graph, this is the transformed graph, right? Now in this graph, can you tell me this point moved to which point I'm asking? This point moved to which point is what I'm asking. You got it?
Yeah.
For you to find that, you have to understand what are these transformations undergone by this. Once you understand that, see your x coordinate, right? Originally your x coordinate became x minus 2. That was the transformation. Original y coordinate here was multiplied by 2 and subtracted 1. So y became 2y minus 1. Now what you do to understand what are the transformed points? All your x values should undergo x minus 2 transformation, right? So 0 became minus 2. You see, 1 became minus 1. All your y coordinates should undergo this transformation, 1. If you have a 1, then it became 2 times 1 minus 1 is a 1. See? So the point 0, 1 on the original graph went to minus 2, 1. Do you get it? The original point 1, 3 became minus 1, 5 in the transformed graph. Am I making sense?
Yeah.
Okay, so the asymptote is y equal to minus 1.
Miss Priya,
Yeah, ma?
can I leave now? I have another meeting.
Go ahead.
Thank you.
So now let's go ahead and try this one. Okay, suppose, let's try this one. Okay. Now what I'm going to do is I'm going to give you the base. You're from a graph, you're going to try writing the equation of the exponential function. Can we try that? We are going to write the equation of the exponential function from a graph. We'll do that. I'll give you the basis 2. Basis 2 means it's a 2 power of x
I have a
function.
question.
Yeah, go ahead.
What does the A value mean?
What is
A value? Is it if it's like
A value is the vertical compression of the vertical stretch.
oh, okay.
A b power of x minus h plus k. You got it? This is the general format. Does it make sense?
What's the K?
K is the up and down movement. H is the left and right movement.
Oh, okay.
Does it make sense?
Yeah.
If this is the vertical stretch or compression.
Yeah.
Am I making sense? Otherwise, you can also write it out as if you consider horizontal compression and stretch, right? Let me not, this is base, if you take it as base, horizontal compression or stretch can be written as, it will be applicable here, 1 by b times x minus h. This they won't usually ask you. They'll always ask you to express like this. Okay, don't get confused with what the vertical stretch, usually they won't ask you to make it a horizontal stretch or compression. Okay, now the base value is 2 and my data points through which the graph passes are 3, minus 1, 4, half. So literally these two are the points through which my graph passes. Okay, and then b equal to 2, the base equal to 2. Let me plot this graph. I don't even know what is this. Okay, once you get a hang of it, it becomes easy, guys. 3, minus 1 is a point in the graph. The other one is 4, half. So my graph goes like this. As I can also give you the asymptote value minus 5 by 2. Asymptote value is minus 5 by 2. These are the minus 5 by 2 is 2.5, right? Y equal to minus 5 by 2. So basically my graph is like this. I have to write the equation of this. Horror to the core, right? Looks like it's horror to the core, but it is not actually. Okay, when you think about it, right? Let's do one by one. The thing is, when you think about the x coordinate, right? It will undergo only this transformation. The y coordinate undergoes a multiplication by a and an addition by k. Any questions on that? So x coordinate underwent only this transformation. So what can I say here? When the x coordinate underwent that transformation only, can I say h is equal to 3 directly? Here, because see, this was 0, 1 changed to 3, minus 1. Do you see it? So, but however, the y coordinate undergoes a multiplication by a and an addition of k. So the y coordinate underwent a multiplication by a and then this was added, right? So that became minus 1. See? Y coordinate 1 was multiplied by a, vertical compression or stretch, and then it was added to k. So now a plus k is a minus 1. Does that make sense till here for all of you? Does it make sense? Now, y equal to k.
I'm confused.
What are you confused on? Tell me.
Why are you multiplying 1 times a plus k is equal to negative 1?
Because the 0, 1, which was the original reference point, what was the transformation that was undergone by 1? It was multiplied by whatever was the vertical stretcher compression, and then it was moved up or down by k, correct?
I'll see, yeah.
You got it? So now a plus k is a minus 1. However, we know clearly that the asymptote is minus 5 by 2. So can I substitute it directly? So that gives you a will be equal to minus 1 plus 5 by 2, which is 3 by 2. A is equal to 3 by 2. When a is 3 by 2, what is k? Minus 1 minus 3 by 2, correct? Minus 5 by 2. Does it make sense? Now plug everything back to the equation. That gives you the equation. H of x will be equal to 3 by 2. The base is 2. Power x minus h is what? 3 plus k is minus 5 by 2. Does that make sense? Does it make sense? Now you know how to check this, whether you got it right or not. The easiest way is substitute 3. When you substitute 3, I have to get my h of x value is minus 1. Am I getting? I don't know. Minus 2 by 2, which is a minus 1. See, you are getting it. When you substitute x equal to 4, what happens? 3 by 2, 2 minus 5 by 2. So that is, what are you getting? When you substitute 4, I substituted 4 instead of x. So that becomes 3 by 2 times 2 minus 5 by 2. So 3 minus 5 by 2 is what? 6 minus 5 by 2, half. See, I'm getting. This is how I compare and check whether I got it right. Does it make sense? This is your final equation. This is your final equation. Do you want me to explain once more? Manav, did you get this? Akash, I'm sure you didn't get this.
Yeah, I got it.
You didn't get much of it, right?
Kind of understand.
Kind of
Just
understand.
like how the equation works.
Which one?
How the equation works.
How the equation works. See, any transformation, right? Any exponential coordinate, right? 0, What are the main reference points? 0, 1 is always a reference point. And then what is the reference point? It is always 1, the base. Here 1, the base is 1, 2 is a reference point. Now what we want to know is where did the 0, 1 move in the transform graph and 1, 2 move in the transformed graph. 0, 1 became 3, minus 1. 1, 2 became 4, half. We know the transformed points. But the biggest obstacle is go from the transformed point, find the equation. Find the equation from the transformed point is a big deal. Why? It becomes very easy. How? Go for the initial reference point, 0, 1. This is h, directly I can't say k because the y coordinate underwent 2, 3 transformations. X coordinate directly was moved to the left or right. So I directly took this as h. H is equal to 3. However, the y coordinate was multiplied by a and added with k. So the y coordinate, which was 1, was multiplied with a and added with k. That became minus 1. See, minus 1 is a transformed point. So from there, I found out what is a, k, and h. I plugged that into my general equation. I got the equation of the exponential function. Shruti, did you get it?
Yeah, I understood. The only question I have is like, is it given which point is 0, 1, like in the start?
Okay. Generally, when you're given the graphs, right, ma?
Mhm.
In a parent graph, 0, 1 always happens first, 1, b always happens second. Okay. When they give you 2 points, you can for granted the same question you asked me last week, I think, right?
I
So,
wasn't there last week.
or the previous week, the same question for another function you asked me. I don't know which function, for a cubic function. Cubic, cube roota function, the same question you asked me, meaning how do you determine the first, there are 2 points only given. Okay. Usually the 2 reference points, the lowest point always corresponds to this, the highest point corresponds to this.
But what if it's like reflected?
If it is reflected, then automatically this is the lowest point, this is the next point, right?
Okay.
You see what I mean, huh?
Yeah, I see.
I understand why the confusion is coming in as well. I'm not denying that you cannot have the confusion. Same question you had, but I do understand why it is coming in again. Okay, let's see one more. Automatically, you'll understand if you do more problems. Manav, are you following?
Yeah.
Manav,
Yeah, I'm following.
1, minus 22 is the transformed point. 2, 5 is another point. Now tell me, Shruti, let me draw the graph. 1, minus 22. 1, minus 22 is somewhere here. Okay. 2, 5. 2, 5. This is the transform point. Okay. Now b equal to 10, base equal to 10. But what is the asymptote? I did not give you that. Asymptote is y equal to minus 3. Asymptote is y equal to minus 3 is my asymptote. So if they give you this, how to find out the equation? Y equal to minus 3 asymptote is here. This is y equal to, it's not making sense. Minus 3, okay. 1, 1, minus 22.
Is it -5, 2, -5?
Sorry guys, this is 2.2.
Oh.
2.2. My eyes are deceiving me. 2.2. This is 2.2. See, that's why. Then it's possible. 2.2 is somewhere here, right? Minus 1, 2.2. 2.2 is somewhere here. So my graph will go like this. Does it make sense? This is my transformed graph. Now tell me, Shruti, which is the transform? The original reference points are what? Original reference points are 0, 1 and 1, 10, right? Which point corresponds to which one?
0, 1 is now 1.
What is near the asymptote, correct?
Yeah.
Yeah. See, now you got it.
Yeah.
So the second one, 2, 5, 1, 10, which was in the original graph, got transformed to 2, 5. Now the general format of an exponential function is h of x equal to a x power of, a b power of x minus h plus k, correct? Now, as soon as you see this, you can find out what is h and k. K is what? The asymptote value, minus 3. What is the H value? H value is
-1
-1 now.
or just 1. Yeah,
One.
-1. It's -1.
X minus H is 1.
At H is -1.
So 0 minus H is 1. 0 minus H is 1. H is -1. Correct. Correct, ma. Go ahead. Directly, you're going to take whatever is given, right? Yeah, see, see, 0 became 1, right? What is H, did you say, Shruti?
You would write it like X -1, right? Or X -1. So I guess H would be positive.
Correct, correct, correct. That's what I got.
Yeah, I was taking like the minus into account, like
Yeah, yeah. When you said that, it felt like it. Yeah. Directly, you'll see, because 0 became 1. Think about it like that, then it's a positive 1. Do you want to go, do you want to solve, guys? Akash, here, if you don't understand, just leave it. There will be some topics that you really understand, some topics that you won't, because you were not there from the first.
Okay.
The next topic you'll understand automatically. When we do word problems, you'll understand.
Okay.
Oh, your class flies like anything. Hey, next week we'll solve word problems. And we'll talk about E and word problems next week. E and word problems and then logarithms. Oh God, okay, there's a lot more. 2-3 classes of logarithmic functions would help. But it would be nice if you can do some regression graphs at home. Type your table values into the calculator, see how can you calculate exponential regression. Manav, I heard there were a lot of problems on regression using calculator and algebra 2 CBE. Did you want to connect with that boy?
Wait, is there like is that regression like that formula like y is like tilde ax1?
Correct,
something?
correct. That, see, for that you just type your table values into the calculator, then
I'm
go
just not
to
sure how to use how to graph on this calculator. I only know how to do it on Desmos.
You have to know see, okay, as much as I know, right, what kids are saying, based on what kids saying, I'm saying, you are provided with both the calculators in a CB exam. Go to the calculator menu, you will see Desmos as well as TA84. You can use either, but then you have to know in TA84. In TA84, you have to know how to calculate any regression, linear regression, quadratic regression, exponential regression. Maybe next week, just remind me, I'll do it in the calculator and show you. Make sense?
Yeah.
But I want to know the equation for this one. At least 1 or 2 answers I really want to get, guys. Do you need help in this? See, H is found, K is found already. So how to find it? The Y coordinate, right? The first coordinate, right? What are the transformations it underwent from 1? That was the original 1, right? 1 underwent a multiplication by A. And then there was an addition of K. K, what is the K value here? -3. That was the transformed Y coordinate 2.2. So now A will be equal to 0.8. Any questions here? Now, how do you write the equation? Shruti, did you get it?
Yeah, I understood it.
Yeah.
So now what is the transformed, what is the equation for this one?
0.8
Yeah, 0.8
times 10
times 10 power of
x.
minus 1
Yeah, x minus
minus
1. Minus 3.
3 by 2, minus 3 marker.
Minus 3.
So that would be equal to h of x. That is the transform function equation. Make sense?
I was doing it, but then I made a
No, if you all understood, I'm happy. Okay, at least most of you should have understood this, how it works. Okay. Okay. For the regression graph, you want me to show you quick, or I'll show you next week. I'll show you next week along with the word problems. Does it make sense? We'll do, see, there are so many different types of word problems for exponential function. Okay. Half-life, double life, all the types of word problems I want to do next week, at least 1 or 2 each. Okay. Half-life, double life, compound interest. Compound interest is a little complicated because they can do compounding quarterly, semi-annually. All this type we need to cover. Let's see how much we can cover. Annually or every second. Okay, so half-life, double life, compound interest, and what else? Growth. Growth can be bacterial growth or a population growth, or it can be decay. Decay in the sense population going down. That can be, and growth can be bacteria multiplies 2 every minute. Okay, after 3 hours, how many bacteria will be there? Things like that. So all these types need to get covered. Let's see how much we can cover. Along with that, I want to show you how to do exponential regression. We'll see whatever we can do, we'll do next week. But please remind me to do it in the calculator. Any questions? For this week, you would have homework on graphing and writing equations of exponential functions with their transformations. Can I stop here? Can I stop here, guys and boys and girls? We'll see you all next week. Have a nice week ahead. If you have a question, stay. Shruti, you're not going to CBE, right?
No.
I'm happy.
Bye.
Bye. What else?